Assalamu alaikum warahmatullah. I'm Nsfcl Hassan. I'm the current student of International Islamic University, Department of Tripoli. I'm the one of the author of this paper, paper ID 24, named Grid Connected Microgrid Fault Current Reduction using Non-Superconducting Fault Current Limiter. The authors of this paper, Nurul Mustafa Tarek, Ainul Farid bin Rahim, MD Rashidul Islam, MD Fakul Hassan, Muhammad Azharul Islam, Department of Electrical and Electronic Engineering, International Islamic University, Chittagong. Our presentation covers why we did this work, objectives of this work, how we did this work, performance of our proposed work. At the end, we will discuss about some advantage and application of our works. Microgrids are becoming an increasingly popular option nowadays. Microgrids have the ability to run in both grid-connected and island modes of operation. But large integration of renewable energy sources is a constant threat because it increased magnitude of fault current when fault occurs in power system. To protect the power system, various protective devices are used, but these are not good enough against high magnitude of fault current. So for this reason, we have designed a system to reduce the fault current. Before we started our work, we read some paper based on different methods fault current limiter. The widespread use of fossil fuels for commercial energy generation is responsible for climate change. So we must reimagine the way we generate to save the environment. Microgrids can be the best solution in this regard, but there are some challenges. This slide shows our proposed system. We have used two fault current limiter at the terminal of PV and biomass to reduce the fault current. Later, we will discuss in detail. Objectives. Designing a microgrid based on PV and another distributed generation. Applying various symmetrical and unsymmetrical fault in the grid side of the microgrid. Observing the proposed response of the fault at the PV and biomass based generation terminal of the microgrid with our proposed Nsfcl. Now we are going to present the total methodology of our work. We designed a grid connected microgrid at first and then applied fault in the grid side. We used non-superconducting fault current. Fault current limiter, which is Sdbr, to limit the fault current. And then we observed the response for 2 line to neutral and 3 line to neutral fault. And lastly, we compared the result with Nsfcl and without Nsfcl and without FCL. This slide shows our design grid connected microgrid. Here we have used two sources, which is PV and biomass. We also added some industrial and commercial loads. We have used fault sensing device to detect the fault. This slide shows our designed PV system. In the PV arrow, we have taken 11 parallel string and 21 series connected string per module. Here, we used an inverter which converts DC voltage into AC. We have used maximum power point tracker, which is a modified P and O algorithm to track the maximum power of the system. To maintain the quality of AC voltage, we applied the control. This slide shows the biomass-based distributed generation, which controls exactly like PV system. The inverter is controlled same as first distributed generation PV. In the end, we connect it to the grid. This slide shows the construction of Nsfcl, which is exactly a Sdbr that we have used in our system. Under normal operating condition, and the current flows through the short path of Sdbr. When fault occurs in the grid side, our designed fault sensing device sent a gate pulse to the Sdbr. Then the short path become open and the current flows through the Sdbr, and thus it reduces the high magnitude of fault current. Simulation and results. All simulations were run in Simulink. Total runtime of all the simulations were 0.75 seconds. Faults were applied in the system during 25 by 60 to 28 by 60. That means for 4 complete cycles. Here is the result for 3 line to neutral fault. In the left, we can see single phase current of PB, and in the right, single phase current of biomass. For the both system, high magnitude of fault current is seen when no FCL is used. With our proposed Nsfcl, we can see the fault current is reduced. In this slide, we can see the clear improvement in single phase RMS current of both systems. From this slide, we can see that the AC power of both systems during 3 Allen fault has been improved whilst using Nsfcl. This slide and this slide, same thing happened for the 2 Allen fault, like previous 2 slides. Here we are presenting the overall percentage improvement of our work. In case of single phase current during a 3 Allen fault, we can see that the PV system improves 30% as well as biomass improves 20%. Since the percentage of both DGs are not same, hence the difference is seen. Advantage and applications. Advantage almost works by an instantaneous operation, fast switching speed, less damage to other traditional protection device and downstream equipment, low cost protection device can be used. And application is can be applied in the real microgrid to reduce fault current level. A cost-effective protection system can be designed. In conclusion, we can say that renewable energy source based generating system are much more improved environment friendly than any other generating system. Our simulation result shows a good percentage of improvement in fault current reduction in both DGs. Thank you.